Question 1. While examining the building automation system, BAS of a 6-story commercial office, Mr. Hanley notices that the HVAC zones on the upper floors are frequently experiencing thermal drift during peak hours. He confirms the system is operating under a static setpoint schedule and that occupant load and solar gains are not dynamically accounted for. What should Mr. Hanley recommend to resolve the issue and optimize BAS performance under variable conditions? A. Implement night setback scheduling to reduce off-hours energy use. B. Increase the duct static pressure setpoint during peak hours. C. Integrate adaptive occupancy-based and weather predictive scheduling into the BAS. D. Just the thermostat calibration for each upper floor manually. Answer. Correct answer. C. Explanation. Thermal drift under variable load conditions points to inadequate dynamic response from the BAS. Integrating adaptive scheduling that considers real-time occupancy and weather ASHRAE 55, ASHRAE 90.1, and BACnet protocols enhances control precision and energy efficiency. Option A conserves energy but doesn't address peak thermal drift. Option B may strain the fan system and lead to inefficiency. Manual thermostat adjustments. D. Are reactive and insufficient for systemic issues. Question 2. During the process of commissioning a newly installed commercial heat pump system, Alvarez identifies that the compressor is short-cycling even though load demand is stable and within calculated parameters. All wiring is verified as correct and the control board is functional. What should Alvarez investigate next to determine the cause of the short cycling? A. Check for oversized capacity relative to building load requirements. B. Replace the run capacitor as a precautionary measure. C. Increase the fan speed to avoid frosting on the coil. D. Reduce refrigerant charge slightly to minimize cycling. Answer. Correct answer. Explanation. Short cycling often occurs when system capacity is oversized for load, preventing the unit from operating long enough to complete proper dehumidification, ASHRAE Guideline 0 and NCI best practices. Option B is speculative without evidence. Option C addresses airflow but not load matching. Option D violates EPA Section 608, which prohibits venting or manipulating charge without documented diagnostics. Question 3. In the context of a healthcare facility retrofit, Mr. Douglas is evaluating the integration of energy recovery ventilators ERVs to improve indoor air quality while reducing operational costs. The building has variable occupancy and high ventilation requirements. Which ERV configuration offers the most suitable balance between energy savings and infection control? A. Sensible heat recovery wheel integrated with a bypass damper. B. Enthalpy wheel with purge section and MER 13 filters. C. Cross-flow plate heat exchanger with integrated UV treatment. D. Run-around coil loop with glycol and manual balancing valves. Answer. Correct answer. C. Explanation. Healthcare applications require minimal cross-contamination risk. Cross-flow plate heat exchangers offer no air mixing and UV enhances pathogen control. ASHRAE 170 CDC guidelines for ventilation in healthcare facilities. Option B, though energy efficient, may allow leakage across the wheel. Sensible only recovery. A. Limits total energy recovery. Runaround coils. D. Are less efficient and harder to balance dynamically. Question 4. The relationship between power factor and motor efficiency in a commercial HVAC rooftop unit is critical. A technician notices the unit's blower motor has a power factor of 0.67 during operation, despite rated efficiency. Which of the following corrective actions will most directly improve energy efficiency and reduce penalties from utility providers? A. Replace the motor with a higher C-rated model. B. Add power factor correction capacitors at the motor terminals. C. Switch to a FET reduce and rush current. D. Rewire the motor for parallel winding to increase torque. Answer. Correct answer. B. Explanation. Low power factor leads to higher demand charges and inefficient use of electrical capacity. Installing capacitors raises the power factor by offsetting the inductive load. NEC 430E141. C applies to cooling system ratings, not motors. A. FDSC help with variable speed but don't correct. Option D is non-standard and may damage the motor. Question 5. From a practical standpoint, Mr. Brody is conducting seasonal maintenance on a large office building's air handling unit. While inspecting the filters, he discovers they are loaded with fine dust and debris. Although it's only been 30 days since the last change, what should Mr. Brody do to address the root cause and avoid premature filter loading in the future? A. Increase the filter change frequency to every 2 weeks. B. Install pre-filters upstream of the main filters. C. Use HEPA filters to trap finer particles more efficiently. D. Clean the filters with compressed air and reinstall them. Answer. Correct answer. B. Explanation. Installing pre-filters reduces the burden on high-efficiency filters and extends their lifespan. ASHRAE standard 52.2. HEPA filters C. Increase static pressure and are not suited for standard systems without modification. More frequent changes, they raise operational cost without solving the problem. Cleaning filters with compressed air D. is against manufacturer recommendations and could damage media. Question 6. Given the circumstances, is Chen is troubleshooting an air system in a multi-zone retail center. One zone is cooling effectively, while others remain unconditioned. The local control boards show no fault codes, and refrigerant pressures are within specification. What is the most likely cause of the issue and the correct course of action? A. The expansion valve for the affected zones is stuck closed and must be cycled or replaced. B. The compressor is failing to deliver sufficient head pressure across all zones. C. The outdoor unit inverter drive is under voltage due to power phase imbalance. D. The system is low on refrigerant and requires topping off. Answer. Correct answer. Explanation. Zone-specific issues in ERF systems are frequently linked to electronic expansion valves (EVs), which modulate flow individually. A stuck EV will prevent cooling even if the system appears normal. ASHRAE 15 manufacturer ERF protocols. Option B would affect all zones. C would trigger a fault. D violates HEPA section 608. Topping off is not acceptable without leak verification. Question 7. The most significant aspect of refrigeration thermodynamics involves the phase change process of refrigerants. Why is the latent heat of vaporization critical to the efficiency of a commercial HVAC cooling system? A. It allows refrigerant to be compressed more easily. B. It provides a means to store heat during the superheating phase. C. It facilitates a large energy transfer with minimal temperature change. D. It reduces the need for high-pressure discharge temperatures. Answer. Correct answer. C. Explanation. The latent heat of vaporization enables heat to be absorbed without a temperature rise, maximizing cooling efficiency. ASHRAE Fundamentals, Thermodynamics Law 1. Superheat. B. Occurs after vaporization. Compression. A. Requires work input, not heat absorption. High-pressure discharge. D. Relates to compressor performance, not directly to latent heat. Question 8. Throughout the course of a routine inspection at a commercial complex, Mr. Gallardo observes that the cooling tower's basin is filled with algae despite the automated chemical treatment system being operational. Heat rejection capacity is also reduced. What is the most likely root cause and appropriate corrective action? A. Increase the chemical feed rate to compensate for biofouling. B. Install side stream sand filter and perform tower cleaning. C. Replace the cooling tower fill media to improve evaporation. D. Shut down the tower and switch to dry cooler system. Answer. Correct answer. B. Explanation. Algae accumulation and heat rejection loss suggest filtration inefficiency and inadequate mechanical cleaning. Side stream filters remove debris from circulating water, and physical cleaning restores performance. ASHRAE Guideline 122020. Legionella prevention. Overfeeding chemicals. A. Is wasteful. Replacing media. C. Is expensive and premature. Switching to a dry system. D. Is capital intensive and typically unnecessary. Question 9. To better understand NEC Article 440's application in commercial HVAC, consider rooftop unit drawing 58 amps FLA. The disconnect switch currently installed is rated at 60 amps, unfused. What is the correct compliance action under NEC guidelines? A. Replace the disconnect with fused 70 amp rated switch. B. Install 60 amp fuse block to the existing disconnect. C. Upgrade the conductors instead of changing the disconnect. D. Use 100 amp non-fused disconnect for flexibility. Answer. Correct answer. Explanation. NEC 440.12 and 440.22 require the disconnect rating to exceed 115% of equipment flow when unfused. A 60 amp unfused disconnect is non-compliant. Installing a 70 amp fused unit meets code while offering overload protection. Option B doesn't address the rating deficiency. Conductor upgrade C is irrelevant here. Using 100 A switch D may oversize protection. Question 10. A demonstrated buyer fault in the economizer operation of a commercial air handler. Mr. Patel observes that the mixed air temperature remains elevated despite cool outside air. The damper actuators respond to commands and sensors appear functional. Which underlying issue is most probable? A. The economizer is configured for enthalpy control, but the enthalpy sensor is reading incorrectly. B. The outside air damper blade is stuck due to mechanical failure. C. The return air fan is off, causing recirculation failure. D. The compressor is running simultaneously with economizer mode. Answer. Correct answer. Explanation. Misreading enthalpy sensors can cause the BAS to falsely reject outside air, defaulting to mechanical cooling. ASHRAE 90.1, California, Title 24. Damper blade issues. B. Would usually show an actuator feedback. Return air fans. C. Affect pressure balance, not necessarily temperature. Compressor operation. D. May be part of integrated economizer design. Question 11. While it is true that nitrogen purging during brazing is time-consuming, Mr. Elkins insists on doing it on all joints when installing copper lines for a rooftop split system. His apprentice questions the need, noting that it seems unnecessary for refrigerant systems. What is the most accurate justification for Mr. Elkins' decision to purge with nitrogen during brazing? A. Nitrogen purging strengthens the joint by creating denser alloy. B. It displaces air, preventing oxidation and formation of scale inside the tubing. C. It reduces refrigerant pressure loss during system operation. D. It is required to meet OSHA HVAC permit requirements. Answer. Correct answer. B. Explanation. Purging with nitrogen during brazing prevents oxidation and formation of scale inside the tubing, which can restrict flow or damage compressors. This aligns with ASHRAE Standard 15 and manufacturer recommendations. K. Strengthening the joint is incorrect. C. Confuses flow obstruction with pressure loss. D. Is a misapplication. OSHA HVAC rules focus on fire prevention, not system purity. Question 12. To illustrate this point, Mr. Renner is analyzing airflow from a VAV system where occupants complain of both excessive humidity and insufficient cooling during part load operation. The supply air temperature is correct and airflow appears steady, which issue is most likely causing the symptoms described. A. The reheat coils are operating simultaneously with cooling mode. B. The system is overventilating, reducing latent cooling capacity. C. The VAV terminal units are improperly modulating dampers. D. The system airflow is too low to maintain proper psychrometric balance. Answer. Correct answer. D. Explanation. Low airflow reduces sensible and latent capacity, leading to poor humidity control despite adequate coil temperature. According to ASHRAE 62.1 and psychrometric principles, airflow must align with latent load. Overventilation. B. Would reduce humidity. Reheat coils. A. Would increase temperature but not cause high humidity alone. Improper modulation. C. Would cause distribution imbalance, not psychrometric failure. Question 13. The core principles of HVAC system zoning involve balancing thermal loads across diverse spaces. In a high-rise with east and west-facing zones, Mr. Cruz notices that the west-facing zones consistently overheat in the afternoon despite shared AHU capacity. What adjustment would best address this imbalance without adding new equipment? Increase the static pressure set point to push more air into overheated zones. B. Install zone reheat coils to offset solar heat gains in the west. C. Reprogram the BAS to adjust airflow dynamically based on real-time zoned loads. D. Add bypass dampers to the east zones to relieve excess capacity. Answer. Correct answer. C. Explanation. Dynamic airflow adjustment through BAS ensures demand-driven cooling distribution and balances zoned loads without hardware changes. ASHRAE 90.1 and IMP zoning practices support this energy-efficient solution. A increases pressure but not control. B requires additional equipment. D risks overcooling, east zones, and inefficiency. Question 14. In comparison with older refrigerant piping techniques, Nolan installs vertical risers in a system with calculated oil traps at precise intervals. His team questions whether the traps are necessary given modern compressors. Why is the inclusion of oil traps still considered a best practice in vertical risers? A. To reduce refrigerant temperature loss during vertical travel. B. To maintain refrigerant velocity in horizontal runs. C. To ensure oil return to the compressor against gravity. D. To create a buffer zone for pressure equalization. Answer. Correct answer. C. Explanation. Oil traps are installed in vertical risers to help return oil to the compressor and prevent it from accumulating in the lines. This follows manufacturer design guides and ASHRAE recommendations for VRF and split systems, and D are unrelated. B applies to horizontal piping, not risers. Question 15. Among the various HVAC diagnostic tools, a digital psychrometer is used by Boyd to troubleshoot erratic comfort complaints in a retail store. The thermostat and supply air appear within range. What specific value should Boyd analyze with the psychrometer to determine the latent performance of the system? A. Dew point temperature of the supply air. B. Wet bulb temperature at the return and supply. C. Dry bulb temperature in the plenum. D. Ambient outdoor temperature and humidity. Answer. Correct answer. B. Explanation. Wet bulb temperatures provide insight into latent heat removal by comparing return and supply air. ASHRAE fundamentals define wet bulb as a key metric in diagnosing dehumidification efficiency. Dew point A is informative but not as comprehensive. C gives sensible heat only. D is external to system behavior. Question 16. From multiple perspectives, technician Izitang is preparing to recover R400 Tina from a commercial system before compressor replacement. She plans to vent the refrigerant from the low side slowly and recover the rest from the high side. What should she do to remain fully compliant with EPA Section 608? A. Use a recovery machine rated for high-pressure refrigerants and evacuate both sides completely. B. Vent the refrigerant from the low side and recover the rest as planned. C. Skip your recovery since R400 Tina is not ozone depleting. D. Only recover refrigerant if the charge exceeds 15 pounds. Answer. Correct answer. Explanation. EPA 608 mandates full recovery of HFCs like R400 Tina regardless of ozone impact or charge size. Venting is strictly prohibited. Recovery equipment must match the refrigerant type and pressure. B and C violate regulations. D is a misinterpretation. Thresholds only apply to leak repair timelines, not recovery requirements. Question 17. The implications of thermal expansion in closed-loop hydronic heating systems are often misunderstood. Western is investigating recurring relief valve discharge from a boiler operating within rated pressure. What is the most probable cause and correct solution? A. Air trapped in the coil due to improper bleeding. B. The expansion tank is waterlogged and not absorbing system pressure changes. C. The aquastat setting is too low, causing short cycling. D. The circulator pump is undersized and causing cavitation. Answer. Correct answer. B. Explanation. A waterlogged expansion tank loses its ability to absorb pressure from thermal expansion, triggering relief valves. This is covered in ASHRAE Hydronics Design Guide and IMC boiler standards. Air traps A cause noise or poor heat transfer, not pressure relief. C affects temperature control, not expansion. D relates to flow, not pressure. Question 18. In response to a confined space maintenance task on a large commercial chiller system, Sanders enters the chiller barrel compartment for inspection. No lockout was performed, but the unit was turned off at the control panel. What critical OSHA violation is present in this scenario? A. Failure to use fall protection inside the chiller. B. Performing maintenance without a confined space permit. C. Lack of arc flash protective gear during inspection. D. Failure to apply lockout gut to isolate all energy sources. Answer. Correct answer, D. Explanation. OSHA 1910.147 requires lockout LOTO on all energy sources. Electrical and mechanical, turning off the control panel is insufficient. B may apply, but the LOTO violation is more immediate. C is not relevant unless electrical panels are open. Applies only to 4 hazard environments. Question 19. As evidenced by uneven temperatures in a restaurant with 2 split systems, Mr. Parker discovers that one evaporator is sweating and the other shows little condensation. Both thermostats are set identically and the line sets are equal length. What is the most logical diagnosis based on the symptoms? A. One system has low refrigerant charge, or a restriction in the metering device. B. The thermostats are not calibrated, causing temperature drift. C. The return grills are undersized on the sweating unit. D. The condenser coils are dirty, affecting overall system balance. Answer. Correct answer. Explanation. Sweating evaporators often signal excessive superheat or improper refrigerant flow. A restriction or undercharge can cause core freezing and erratic operation. EPA and ASHRAE troubleshooting charts support this approach. B affects control, not mechanical flow. C would restrict airflow but not cause sweat. D affects outdoor side but would impact both units if shared. Question 20. By evaluating compressor performance data, Mr. Richards notes that the suction pressure is within range, but the discharge pressure is 15% higher than expected under identical conditions from a previous inspection. The system uses R407 can has a clean coil, which condition best explains the observed performance issue. A. The evaporator coil is partially frozen, increasing back pressure. B. The system is overcharged, raising head pressure. C. The expansion valve is underfeeding refrigerant. D. The condenser fan speed is too high, reducing subcooling. Answer. Correct answer. B. Explanation. Overcharging leads to elevated discharge pressures and reduced system efficiency. This aligns with EPA 608 service guidelines and ASHRAE refrigeration cycle principles. It would lower suction, not raise discharge. C causes low suction and poor superheat. D would increase subcooling, not head pressure. Question 21. The prevailing attitude toward electrical control troubleshooting is that relay failures are easy to diagnose. However, Mr. Lawrence is called to a facility where the condenser fan on a commercial split system intermittently fails to start even though the contactor engages and line voltage is present at the terminals. Which diagnostic step should Mr. Lawrence take next to pinpoint the root cause? A. Measure amperage draw at the fan motor terminals while the system runs. B. Replace the run capacitor and test operation again. C. Inspect the control transformer secondary voltage. D. Check voltage drop across the contactor under load. Answer. Correct answer. D. Explanation. A faulty contactor may show correct voltage at terminals, but exhibit voltage drop under load due to pitted contacts. Measuring voltage drop across closed contacts ensures reliable function per NEC 430 and HVACR best diagnostic practices. Amperage checks are useful but secondary. B is a guess. C relates more to low voltage controls, not line side fan failure. Question 22. By evaluating the condenser water return temperature from a centrifugal chiller, Mr. Farrock finds it consistently 6 higher than the manufacturer's design return temperature even though the load hasn't changed. The cooling tower is running at full capacity. What is the most likely cause of this inefficiency? A. Foul condensed tubes reducing heat transfer. B. Incorrect set point on the building management system. C. Cooling tower fan operating below full speed. D. Improper refrigerant superheat setting. Answer. Correct answer. Explanation. Foul condenser tubes impede heat exchange, raising return water temperature and forcing the chiller to work harder. This is a common efficiency issue addressed in ASHRAE Guideline 22. B might affect load demand, not return temp. C would lower airflow but was ruled out. Superheat. D affects evaporator, not condenser efficiency. Question 23. Taking into account OSHA and EPA requirements, technician is Callahan is about to work in a mechanical room containing multiple refrigerant-based systems. The space is confined and has no mechanical ventilation. What action must is Callahan take before starting any recovery or repair work? A. Begin refrigerant recovery immediately since EPA requires it before opening any system. B. Confirm that oxygen levels are above 19.5% using a portable gas detector. C. Request mechanical ventilation and ensure refrigerant sensors are active before entering. D. Open doors and windows to ventilate the room naturally. Answer. Correct answer. See explanation. In confined spaces with refrigerants, OSHA 1910.146 and ASHRAE Standard 15 require mechanical ventilation and active monitoring of refrigerant concentrations to avoid asphyxiation or toxicity risks. B is also critical but does not satisfy the full requirement. A is premature. D is insufficient for confined space compliance. Question 24. From a historical standpoint, analog gauges were industry standard, but Feldman now uses digital manifold gauges for all service calls. During a diagnosis, the digital gauge shows pressure fluctuations every 2-3 seconds while the system runs steady. What is the most probable cause for this behavior? A. Faulty pressure transducer in the gauge. B. Pulsations from the compressor due to short cycling. C. Restricted Schrader valve causing intermittent flow. D. Minor refrigerant leak near the gauge connection. Answer. Correct answer. See explanation. Restricted Schrader valves or partially open service valves can cause erratic pressure readings on digital gauges. This is a known diagnostic artifact and should be resolved by ensuring full valve opening or temporary removal. Options and D are less likely without evidence. B would affect system operation, not just readings. Question 25. The underlying principle of heat exchange in evaporator coils involves both sensible and latent heat removal. In a properly functioning DX coil, the majority of the refrigerant evaporates at a constant temperature. Why does the refrigerant's pressure directly determine the coil's heat absorption capability? A. Low pressures allow faster refrigerant circulation, improving heat transfer. B. Refrigerant pressure controls the boiling point, which defines the coil temperature. C. High pressure creates more turbulence in the tubing, enhancing performance. D. Pressure increases refrigerant volume, enabling greater heat absorption. Answer. Correct answer. B. Explanation. According to thermodynamic laws and ASHRAE fundamentals, refrigerant pressure determines the saturation boiling temperature, directly influencing coil temperature and thus heat transfer. Low pressure equals low boiling point equals better cooling, and D are false principles. C relates to turbulence, not temperature. Question 26. While analyzing a complaint from a commercial property manager, C finds that airflow is correct, equipment is functional, but tenants complain about being too hot in one area and too cold in another. The building automation system has preset occupied and unoccupied modes. What should C communicate as the most likely cause of the inconsistent comfort? A. The zoning dampers may be misaligned or out of calibration. B. The economizer is introducing too much outside air. C. The system is due for refrigerant recovery and recharge. D. The thermostat wiring is reversed. Answer. Correct answer. Explanation. Misaligned or failing zoning dampers often lead to uneven temperature distribution across zones. IMC and ASHRAE 90.1 support using calibrated zoning controls to ensure consistent comfort. Economizers. B. Affect fresh air, not distribution. C is unrelated unless symptoms confirm it. D would cause system behavior issues, not comfort imbalance. Question 27. As a result of routine PM inspection, technician Lopez observes a burnt terminal on a contactor in a rooftop unit that still functions intermittently. What is the most appropriate action to take next? A. Leave the contactor in place and monitor on the next service visit. B. Sand the terminal clean and tighten the wire connections. C. Replace the contactor immediately and inspect wire terminals for heat damage. D. Replace the wires only and leave the contactor in place if functioning. Answer. Correct answer. C. Explanation. A burnt terminal indicates arcing or heat buildup, which can cause catastrophic failure. Per NEC 110.14 and NFPA 70, replacing the component and checking connections is mandatory for reliability and safety. And B. Risk failure. D. Ignores the likely internal damage to the contactor. Question 20. When faced with an airflow complaint in a dual-zone split system, Mr. Jennings notices that the return duct in Zone 2 is 8 diameter while Zone 1 is 12, even though both zones are the same size. What is the likely consequence of this return duct mismatch? A. Zone 1 will have more humidity issues due to higher airflow. B. Zone 2 will experience short cycling due to higher static pressure. C. Zone 2 will have lower return airflow, reducing cooling capacity. D. Zone 1 will overheat because of uneven refrigerant distribution. Answer. Correct answer. C. Explanation. Smaller return duct in Zone 2 restricts airflow, lowering cooling capacity and potentially causing comfort complaints. According to Manual D and Inc., duct sizing, ductwork must match zone load is unlikely unless coil is oversized. B could occur, but C is more immediate. D is unrelated to airflow. Question 29. Across different scenarios, Mr. Elliott reviews log data showing that a rooftop unit's energy use spikes dramatically every morning for 30 minutes, then stabilizes. Occupancy begins at 9 a.m., but the spike occurs at 8:30 a.m. What is the most likely explanation for this daily pattern? A. The economizer is malfunctioning and drawing in warm air. B. The unit enters warm-up mode with full heating enabled before occupancy. C. The VFD ramp-up is configured too aggressively. D. There is refrigerant leak triggering the defrost cycle. Answer. Correct answer. B. Explanation. Commercial systems often use warm-up or morning startup to bring zones to set point before occupancy. This can cause a spike in usage. ASHRAE 90.1 allows scheduled preconditioning but should be tuned to minimize peaks. Economizers A. Don't explain heat spikes. C. Affects fan ramp up, not heat. D. Only applies in heat pump mode. Question 30. According to recent studies, many commercial HVACR installations fail inspections due to improper condensate drainage. In a system with a vertical AHU in a mechanical closet, Mr. Thompson observes no secondary drain pan or float switch. What is the code-compliant correction to prevent water damage? A. Replace the primary drain with a larger diameter pipe. B. Add a second drain pan or a water level detection shut-off device. C. Install a condensate pump to expel water at intervals. D. Reroute the existing drain to exit outdoors. Answer. Correct answer. B. Explanation. Per Inc. Section 307, when equipment is installed over finished spaces or where leakage could cause damage, either a secondary drain pan or an overflow detection device is required. A larger pipe. A. Doesn't prevent overflow. C. Is useful but not code required. D. Doesn't address shut-off or overflow prevention.